Hi everyone. In this video we'll talk about what area is. So yesterday I asked you to consider the following question. Which of these two regions has an area that's easier to compute? Now I'm sure most of you correctly identified that this region has an area that's easier to compute than this region. But why? Why is it easier for us to compute the area of this region than this? So some of your answers were that this is comprised of straight line segments, whereas this is comprised of curves. And that's definitely true. That's a part of why it's easier to compute this area. But why do straight line segments make this easier? Some people said that, well, we have formulas for the areas of things that comprise this. Like we could break this up into triangles and squares and rectangles and so on. And we have formulas for all of those things. We don't necessarily have easy formulas for whatever these kinds of shapes are. And that's also true. But of course the question is still why? Why do we have formulas for areas of triangles and squares and trapezoids and things like that, but not areas for these kinds of irregular curved shapes? So these questions get at the heart of the question, what is area? So a good place to start with the question, what is area, is to dimension down one and think about the question, what is length? So here's a pen, and we want to talk about the length of this pen. So length is a one-dimensional measurement. We want to assign a number to this pen that somehow describes its length. Now the secret to this is that we invent a ruler. Basically, we take something straight and mark out numbers on it, and now we have something to compare to. And we can put our pen against this ruler and say, all right, well, this pen is about 5 3/8 units on this ruler. So that is its length. Before we can assign these numbers, though, we have to decide on what our unit is going to be and what we're going to compare to. So what does that decision look like with area? Well, it looks like this. For area, we decide that we're going to measure area in unit squares. In fact, that's why we measure area in square units, because that's what the basic fundamental unit of measurement of area is. So if we have an object like this, the question is simply, how many of those little squares does this thing occupy? And if we can compute that, then we can figure out what its area is. We can assign a number to its area, which is a two-dimensional measurement associated with that figure. So the basic fundamental unit of area is a square unit. And in fact, that gets to our axioms of area. There are three axioms or postulates of area that we adopt. The first is that the area of a square is its side length squared. The second axiom of area is that if two figures are congruent, then their areas must be equal. And then the third axiom of area is that if you have a figure and you dissect it into two pieces, then the area of the figure must be equal to the sum of the areas of the two pieces, assuming that they're disjoint, that they have no overlap. With these three axioms of area, we can prove everything we need to about the areas of polygons and any straight-edged objects, like here. Finding the areas of curved objects will require some ingenuity. We'll only look at one kind of curved object in geometry, but by the time you get to calculus, you'll be finding the areas of all kinds of curved objects.